So what's the plan? I'll do my thing and then we just chat for a little bit.
So at 8:05, once we've got kind of a group in here, I will just do a little quick intro and then I'll hand it off to you. I've got like 2-3 slides, just so people know where they can contact us and if they want to submit their own talks and so on and so forth.
Oh, cool. I'll try to be, I might go a little bit long. I'll try to be fast.
Yeah, no problem. And then, yeah, after you talk, we'll usually just do the breakout rooms for people to meet each other and say hi and whoever wants to stick around. So
we have a guest. Hi, Philip. This is Philip. He's from Rockstar Games. He helped me out with this, actually providing some invaluable feedback, and he's a network programmer at Rockstar. So
awesome.
It's nice to have him here. He's a very smart guy. He wrote this crate called Rafix. Am I pronouncing it right? RAFX, which is a different style of graphics crate. You know, okay. I guess it's a what do you exactly call it? It's like an alternative to things like Volcano or
Oh, okay.
Or whatever. But yeah, he can talk about it, not me. But that's how we got in touch because I've been integrating it and it's really, really clever. And we agreed immediately, I think, on a lot of things that that we like about implementing crates in a certain way and I will be mentioning a few of the things here. So
awesome.
Yeah,
welcome everybody, and welcome back Jason, who was our speaker last time. Thank you for coming back. We'll give people some time to filter in here, and we will start the talk at 8:05. But welcome everybody. I see we've got some folks from Game Breaking. Hey, Kevin. So when did you start using Rust?
Me?
Yeah.
Oh, about 3.5 years ago, 3 years and plus. Yeah, something like that. So I'm not one of the original guys.
What got you started?
Well, it's one of the things I mentioned here. It's just the endless pursuit of getting away from C++. Mm-hmm. That's pretty much it. Again, but it was love at first sight. Like I said, I don't want to get ahead of myself, but yeah, it was.
Well, you've been in games for a long time, so I mean, you've probably been writing C++ for decades now.
I wrote the first. Well, I started in C in around 1981. Mm-hmm. The very first thing I did writing in C was a copy protection scheme. I come from Italy, and copy protection back in the 80s was a big deal. It was a copy protection scheme for the Apple II disk drive. It was a crazy thing. But anyway, but it was the first thing I wrote in C. And I didn't mind C. C was a huge, it was like a high-level assembly language in the days of the Apple II, and it worked really well. And then C++ started being, shoved down our throat around the late 80s, early 90s. And yeah, I've been using it ever since. And but I still remember it was, I think, 1991 or so when they introduced exception handling. I still remember that part. And thinking to myself when I saw that, I'm like, oh my God, they're screwed. Nobody's ever going to use this. It seems so insane to me. Little did I know that 30 years later, we'd still be, there. So, yeah. So I'm not a huge fan, let's put it that way, even though I've used it for my whole life, pretty much, almost. So yeah, so that's the.
Well, I'm curious, what were your coping mechanisms for C++? A lot of different studios approach it in very different ways, but
that is another thing. I mean, there is no such a thing as C++, really. I mean, it's all just a subset of C++. It's C. I'm talking about the game industry, of course. It's it's C with a subset of C++ to make C a little less sucky. That's about it. And that subset is never the same. Every company, every studio, every group has a different subset. There are a few things in common. Like, again, nobody uses exceptional handling or runtime type identification or these things that are just ridiculous. But the various flavors of it, are just completely variable depending on the place that you go to. So my coping was just that, that's all we had, and kept looking for alternatives and thinking, some days at some point something will make sense. I actually wrote a whole thing. I've been writing for about 2 years, and it's a whole brain dump about why these tools are still around and why they're so wrong. And it's, like I said, I mentioned a few of these things here, but I normally go way deeper on that stuff. And like I said, it's just not well organized, but at some point I'll either put it somewhere like an essay or something like that. But I've been thinking about it a lot over the last, but it's really this last decade that I've come to the point where I just couldn't take it anymore. It comes to a point where you go, it's just, this is costing us so much in terms of, loss of productivity. And again, so maybe I didn't cope as well as I could have, because obviously I wasn't very happy about it. Another thing is that things shifted a lot. And again, it's another thing I mentioned, but things shifted a lot to, you're really programming like engine programmers and artists and so forth. They now, most of their time, you put together a nice little backbone and that's it, and you barely ever touch it. The people who really go stuck with C++ was people doing simulation, doing core gameplay logic, those kind of things, as opposed to either the high level or the lowest level. They tend to, it's the stuff in the middle that is really the worst. Anyway.
Cool. Well, let me kick us off real quick.
Yeah, sorry.
I'm gonna take over the, no problem at all. I think that's a good conversation. I'm gonna take over the screen sharing for just 1 second.
Yeah.
Just to introduce, hello everyone. Welcome to Rust Los Angeles Meetup. Can everyone see the screen?
Yep.
Cool. I'm Drew, if you haven't already met me. I am one of the organizers for the Rust Meetup. I run a small work-for-hire shop in the games industry. We're sort of based out of Los Angeles. I'm not writing Rust professionally yet, fingers crossed, but I have done it as a hobbyist and made some small games and small programs with a couple of my coworkers and friends. If you ever need to get a hold of me, there's my email. And as you'll see on future talks, if you want to help, or future slides, you can email me if you want to help us out. Cameron, as our other organizer, would you like to give a quick intro for yourself? Awesome. Yeah, and if you'd like to submit a talk, we do these every month. It's the, I guess it's the second Wednesday of every month that we're doing these talks. And if you want to help us organize, you can email me directly. We've got a little website at rustling.la to find updates on our future talks, to submit your own talk, and to join, we actually have a little Slack channel as well. Usually we, start off with intros right about now. I guess this is take 7, change it to 8. And then we give a talk for somewhere between 15 minutes and a half an hour. And then around 8:45 or whenever the talk finishes, we'll do a breakout room or two, depending on how many folks want to stick around and meet one another. I think it's a good chance to network and say hi and see who else is doing work in the space. We have our sponsors, people paying for the websites, the Zooms, etc. Cameron can tell you about the first two, and I can tell you about the second. And then, of course, Game Breaking Studios is the company that I work for, and the company pays my Zoom. And AirChat is Jonathan Wilner is one of the founders of AirChat. They're a new startup that's hiring for Rust right now, actually, for some of their SRE positions. So if you're interested, go ahead and shoot them an email, jonathan@getairchat.com. And without further ado, our speaker today, well, I'll let him introduce himself, actually. Here, let me take this down.
Yeah. Hello, everyone. Yeah, my name is Andrea Pessino. I'm the co-founder and now head of research at Radio Dawn Studios. I used to be CTO, and since we were acquired by Oculus Facebook Gaming last year, now I'm head of R&D, and I'm a huge Rust fan, and so I'm here to do a little bit of a friendly. Let me actually zoom this back up. I do not see my slides anymore. Do I need to reshare?
Oh yeah, sorry, go ahead and share again.
So, okay, maybe there. Uh-oh. It's not letting me, and I don't have my mouse anymore.
Let me try to make sure that you still have, you're still a co-host.
Hold on, let me stop sharing. Let me try again.
Yeah.
I don't understand because I can't even click on anything. Oh, okay, it's back. Let me try again. Maybe because it wasn't full screen. I don't think so. Okay, let me try again. Try that. Nope. Okay.
Oh, I have something.
You have something?
A white screen and a cursor.
Okay. All right.
There we go.
Should work now. Okay. There we go. Happiness in Rust. Okay. Let's just get started before it dies again. Okay. So let's do it. So again, this is going to be kind of a low-key little chat about Rust more than anything else. So a few years ago, I was watching a talk by Jonathan Blow, a very smart and very opinionated game programmer and designer. He was the creator of The Witness and Braid a few years ago. I'm sure you know him. Everybody knows him. Anyway, he was talking about how he was going to create a whole new programming language specific to his needs because the development tools available to him felt inadequate. Actually, he said more something like this: C++ bums me out. And I never would have quite expressed my feelings like he did, as directly as he did, but I sure could relate. And this was the first time that I ever heard anybody do a critique of C++ as a measure of happiness. But really, it really does sum it up nicely, in my opinion. So it made me think, because C++ has been bumming me out since at least 1992, to the point where I have spent great amounts of effort trying to minimize the proportion of my coding time spent in C++. I went with, extensible scripting languages, compiled, interpreted, third-party, custom. I wrote my own things. I tried my own designs, looked at every language, old and new, searching for an alternative that had to be practical enough for our needs, or at least something that I might be able to evolve to become, practical enough for our needs. Ideally, I would have loved a general solution, something that I could use, one language for everything I need, as opposed to now that we have different, at least 3 or 4 in any one project. And there wasn't one. It was a journey, and I did learn a lot, of course, because you learn things by searching. But at the end, I failed, and whatever we attempted to do would end up just too compromised in one way or another. There was always something that wasn't there. And back to C++ we had to go. And, I'm a game developer, and we have very specific priorities and challenges. Our needs are by no means universal in this really vast landscape that modern software engineering has turned into. But our needs do line up with what I guess now, I confess, I never heard that term before Rust, but I guess now it's systems programming. We're definitely systems programmers in most, in most ways, or performance-oriented engineering. Our main concerns are performance. In games, performance is a critical priority. More than that, it's a competitive advantage. It actually lets you create better products and deliver experiences that are more distinctive for your players. And leaving performance on the table, in general, is just not an option, especially for AAA games. And then, games have become huge in scope, in ambition, and both creatively and technologically. And also, there are so many disciplines now that go into the creation of a game: content design, testing, and all of them, for the majority of time, are bound by the quality of our tools. So in almost all cases, coding is the bottleneck for the largest portion of game development. And to manage the growing complexity, we need, on one side, we need better production strategies, for sure, but we also need just better software engineering. The days of games being a bunch of hacks and, shortcuts slapped together are gone, or at least they should be. And finally, correctness. If you're a game player, you have likely experienced that in games, complexity and performance often take priority over robustness. QA is a huge challenge and a huge cost, and results are often still really not ideal. Also, there is to consider that compared to like general application development in games, you typically don't have the luxury of, closed betas and things. I mean, some games do now, and some with early access do things like that. But for, tentpole, large games, you just can't do that. You depend on a relatively tiny number of people testing the crap out of your game. And, if you could be more correct and more robust ahead of time, it would be a gigantic, cost-saving measure, besides, helping you deliver a better product. And of course, game coding is intense. In fact, all game development is intense. You got requirements, expectations, timelines. They make game development very stressful, and that's when everything is going well. And of course, these tools don't help. So why are we still using unproductive, obsolete development tools? More specifically, why do we use obsolete engine development tools? These days, few studios make their own technology. Most either license a third-party engine, or maybe they share tech at a publisher level. Either way, if you write or you customize or just use a low-level, engine, a low-level game tech, you're going to have to use C++. There's really no other choice. We are one of the very few studios left that do make all of their own tech in-house. We do everything. We use very little in terms of middleware. We had to start that way because when we started with the PSP, and there was absolutely nothing on the PSP. And so we had to begin by creating our own technology. And that became also one of our, primary assets and one of our defining, characteristics that we target platforms very specifically. But still, it makes sense that most studios wouldn't even entertain that notion. And of course, that means that they're even more locked into their ecosystem. So at least since we make our own tech, we are in a position to at least entertain and explore the optional alternatives to C++. And the sad reality is that we as game tech coders and other, performance engineers are kind of stuck. There are many complicated reasons for this. Like I was mentioning earlier, I've been writing a large tome on this subject that someday I'll finish. But to sum it up, it's all about control. Performance comes from control, and for better or for worse, with C++, you're in control. For a very long time, really, this was all there was to it. There were no meaningful alternative for this reason alone. And the most we ever got were various flavors of like a better C, and that's just not enough. Every game studio I've been to has at least has gone through a C that sucks less, phase, and I mean their own version of C that has a module system that is not a relic from the 1970s or some fancy feature from another language, but none of that is going to cut it because you're not fixing the fundamental issues. The net result is that we've been using essentially the same tools and the same techniques for at least 35 years. In spite of the fact that these tools are not just unproductive, they're actually counterproductive. So Rust is the alternative that has a chance, in my opinion. As of now, it is a mature, practical, meaningful solution to the problem. Of course, there are still some obstacles. Powerful economic and technical inertia is the biggest obstacle, in my opinion. Hitting escape velocity is not going to be easy. It will take a long time, but I think it's doable. I'm working on this myself, and at some point we might share more about how we're trying to do it. Of course, it's not like we can throw away 18 years of R&D and development and paralyze, 150 people at the studio. We can't just start from scratch. So we need to figure out a realistic and even desirable way of moving forward without, any drastic and insane measures. Another thing that is still an issue is on some platforms there are still issues, and your development tool needs to be supported on all your target platforms. Otherwise, it's a non-starter. In the case of Rust, I think we're very close to have general availability, but there are a few issues left. And they're not really actually technical issues anymore. They're more like bureaucratic issues, let's put it that way. And they're really easy to solve with a little pressure. All it takes is a couple of the big players to, push just a little bit. And lastly, Stockholm Syndrome. I think the fact that anybody would still discuss, the C++ as a, meaningful option, and to me, smells of Stockholm Syndrome because I don't get it. Game coders tend to be very passionate, artistic, hardcore, and very opinionated. And the willingness to embrace change is often a bit in short supply. But in the case of Rust, at least, I see this improving a lot, especially recently, maybe because, some of the really big players are making incredible moves just today with that, Linux, having parts of the kernel being rewritten in Rust. Holy crap, that is just, that is humongous. So Microsoft, Facebook has, Amazon, they all seem to be making moves towards Rust for one very good reason. Rust is better. And I'm not going to evangelize today here. I do that a lot, but it seems unnecessary given the audience. I assume, we're on the same page. Let me just say and get out of my system that I was blown away by Rust before I even wrote a single line of code with it. I literally got emotional just reading about the ownership model. Rust is the language I wish I had been smart enough to design myself, because I designed a whole bunch and I never came close to coming up with something this profound. It actually revitalized my love for programming. And again, I've been coding for 40 years, and it's rare for me to feel that there is a genuine advancement happening, in our field. And with Rust, my code is more performant, more versatile, more productive, much more robust. I don't even think this is up for discussion anymore. It's set, it's a fact. And Rust is important. Rust is so important because it is the first step in the right direction in at least 2 decades, in my opinion. Software development is critically more expensive and less effective than it needs to be. And again, I'm not just talking about games. In fact, I would say that software development is flat out broken, all of it. We're not going to do a deep analysis, but I think it all boils down to just one thing: hardware. Current hardware offers performance through devices that current software is unable to model. If anything, the gap between the hardware's potential power and the software's ability to harness it has been widening. And I promise you, this is not because software engineers are getting worse or because of their education or any other jaded old person type of nonsense. the ratio of good programmers to bad ones is the same as it's always been. And I think the programs that are good now are better than ever. And then complexity. As much as our tools fail to map hardware architectures, they fare much worse when it comes to managing complexity. Modern software systems are just too massive, interconnected, dynamic, and deep for these old techniques. And if performance is subpar, reliability, productivity, and safety are a disaster. And yeah, there are exceptions, for example, GPU programming. But if you think about it, why is it an exception? Because GPU tools have been conceived and they've evolved to model their target hardware. I mean, we've already had 2 revolutions in general GPU programming, and the whole thing is only about 25 years old. More evidence that a lot of the issues with general software are a direct consequence of the obsolete tools we're stuck with. Now, I don't know how many here are familiar with ISPC, but ISPC is a language created by researcher Matt Farr. I hope I pronounced his last name correctly. He used to be at Intel, now he's in NVIDIA. Many know him because he was one of the main authors of a physically based rendering, you know, really important book in graphics. So kind of a smart guy. ISPC was inspired by shader languages. I'm not going to have time to get into the details here, but I really, really recommend you look into ISPC if you're not familiar with it. And regardless of whether you need ISPC or not, its creation, the history of its creation, how it came to be is super interesting. And its lessons scale to software engineering in general. You can just Google Matt Farr's blog and look for the story of ISPC. I think it's like 11 chapters, but every word is fantastic. So what is ISPC? ISPC, in just a couple of sentences, it offers a concurrent programming model for CPU vector units. And it compiles too many targets. It came from Larrabee at Intel, and it came from the war between compiler people trying to create an auto-vectorization solution, and Matt and other software and graphics guys being convinced that there is no such a possibility, that auto-vectorization is just not possible, that what it was needed instead is a new abstraction specific to vector units. So I've done a lot of work with it recently, and the results have been just incredible. We have taken sections of existing highly optimized, I mean, this is code, math-heavy simulation code that we developed and refined over a decade, re-implemented them in ISPC and got remarkable performance gains. But consider that the hardware is the same. This is highly optimized code. The algorithms are the same. The only difference is that the abstraction is ISPC's data concurrency model instead of just C with SIMD intrinsics. Even more remarkable, ISPC's abstraction over the vector hardware is just ridiculously simple. I refer you to Matt's blog post for details, but again, it all boils down to one thing. Vector units needed a model. The key to expressing the performance potential of vector units was a suitable abstraction, much like it was the case with GPUs. And guess what? What ISPC does for vector units, Rust does for concurrent computation, for performance, for safety, and for scalability. Ownership is Rust's programming model. It's its critical differentiator. Everything else about Rust is wonderful. It's modern, effective, but it's basically a bonus. There you go. Elle Woods said it best. Okay, so maybe she wasn't actually talking about Rust ownership, but the point stands. While ownership rules are simple, their consequences are not. And the reality is that ownership is the key to happiness in Rust. I think we can all agree that becoming comfortable with ownership, or the borrow checker, or whatever you want to call it, is by far the most challenging aspect of learning Rust. I mean, it has certainly been for me, and I think it's been for everybody that I've watched trying to learn Rust. I also noticed that generally, and again, at this point, I've watched quite a few people get into Rust and learn it, and react to it. And these were all very experienced coders. Learning Rust goes something like this. First, excitement. You come to Rust while serving a C++ life sentence. You start off strong, everything makes sense. You can't wait to dig deeper, sky's the limit. And then as you get more ambitious with your types, your APIs, your crates, you hit a bump, unequivocally against the borrow checker. Sometimes you even get stuck. You borrow yourself into a corner. That happened to me a lot. Well, not a lot. I don't want to sound like an idiot, but it happened more than I care to admit, I guess. You may even question if it's all worth the aggravation, and you may say bad words. And then you get over the bump. You rarely argue with the borrow checker anymore. I certainly don't. I have zero trouble expressing any type of data structure or algorithm that I care about, no matter complexity, no matter the target, the architecture. And if you do even have occasional, trouble, it's because you're pushing the envelope. You're testing the limits. You're getting into, the fringes of the language or performance of a platform, and happiness follows. The next thing you know, you're voting for Rust as the most loved language on Stack Overflow. So can we help, people through that transition? So the rest of this is going to be about coming up with a few actionable suggestions, something again, very high level. The goal is to help those that have begun exploring the language minimize the inevitable early frustrations, and they're going to be there. And we're going to keep it a very high conceptual level. These are not meant to be like Rust gems, although we should totally start doing those too. We're not going to tell you to use this trait or that type or do this thing. They're more like spiritual advice, the kind of thing that you would put on a Rust motivational poster with mountains in the background. So here we go. 9 secrets for Rust happiness, and you're not going to believe the 4th one, or something like that. So first, you have to embrace correctness, love being explicit, reject global state. So these are really just good coding practice, right? Especially in the modern programming context. You need to make your peace with them, because as you will find out, Rust does not make them optional. You don't want to approach learning Rust by challenging its core principles. In fact, you could add the following statement to each of them. Yeah. And by the way, for our hypothetical C++ programmer, love being explicit might be a challenge. Giving up operator and function overloading, implicit typecast, and various other C++ horrors will require some detoxing. And they just need to get over it. There's nothing else we can do other than tell them, it'll get better. So once peace has been made, we can move on to actually more practical advice. Like this: ownership is not aggregation. So let's start by looking at a super simple struct, right? So in C++ is the key. These are just, it's a struct with 2 data members. Couldn't be any easier. One of them is a vec for good reason. In C++, if we forget about inheritance and whatever else, so let's say in C, a struct like this only expresses aggregation. There is no other contract made about the relationship between the data members or how their access will be arbitrated. The has a relationship that we all got, drilled into our brains is just about memory layout and lifetime. It means absolutely nothing to the language. In Rust, thing owns its data members, and the borrow rules make it so that it's not just a semantic difference. The data members in thing have the same owner, and this has implications, especially with aggregate or container types or algebraic types. For example, here's your most classic Rust error for a beginner, or maybe not even a beginner. Straightforward, mutable iteration, over elements. We want to update the state of each entry. This, of course, does not compile because self is borrowed mutably and then immutably. For beginners, the majority of borrow checker fights, I've noticed, originate from a variant of this pattern. I'm mutating a value owned by thing, but now I can't see the property of thing. And notice that I didn't say just the data members. Properties also means, methods and whatever else. So of course, in this bare bones example, fixing the problem will be trivial. You just make a static function pass the element to update, and the data, done. But in real world scenarios, a thing might be a piece tangled in a complex system. Maybe a thing is even a published type in another crate meant to be extended by external users. That element update loop might be something that you're supposed to refactor yourself or combine yourself. Regardless, by construction, we will not be able to call a method on thing while we are mutating an element. And I don't know if you can go back into your old C++ self, if there is that, but we have to stop and think about just how foreign that can seem to someone, getting started with Rust. You're not going to be able to do it without going through some serious hoops, if at all, Anyway, this might not even matter, or might even be by design. Maybe that's exactly what you want in that case, but it has to be deliberate. So what is the core realization here? A value should never depend on its owner. When we borrow elements out of thing, we are effectively giving elements away. It's just like a move, except it's presumed to be reversed at some point in time. Element state is now exclusively, and that's the key word, comes with Rust. It's always exclusive mutability. So it's exclusively managed by whatever we lent it to, and its connection to thing is temporarily cut. It follows naturally that the item has also lost its access to us, or to thing in this case. And this must be a consideration when designing data. We can't think like we used to in C++, where you stuff all the data related to an object into a class, then pass the class around, just in case, regardless of what parts of it we actually need access to, or when, or how. Or even if you ever need access to. In Rust, it is essential that we are granular and deliberate in defining data access patterns. Ownership concerns lifetime and storage. In our example, the way to allow dependency would be to split the element logic, the shared data, and the container of elements into separate types without any mutual ownership, which brings me to a further suggestion, which is delay ownership. Anytime you commit to an ownership relationship, you are reducing the versatility of your data types. Where possible, postponing storage and lifetime decisions to a higher level results in more flexible APIs. In the end, everything that we're discussing is an emergent property of Rust ownership rules. Much like with ISPC, that had this incredibly simple abstraction, Rust ownership rules are trivial by themselves. But all of this and a lot more, emerges as a consequence. And to sum it all up, ownership is not aggregation. Back when I was learning Rust, I used just this sentence as a mnemonic to remind myself of these new design principles that I needed to keep fresh in my head. It helped me make safer architectural decisions while I was still discovering its more subtle aspects. Helps you not borrow yourself into a corner, as might be the case. And then grow horizontally. Traits are not classes. Rust is not an object-oriented language, thankfully. And yes, of course, you can still, implement object-oriented concepts, and there are parts that, but unless, if you don't have inheritance, you can't call a language object-oriented. Traits express parametric polymorphism, which is a completely different abstraction than subtyping. And much like we recognized earlier with ownership and data structure, it is important to move away from this need to composite. Don't think of functionality as a hierarchy, widening from the bottom up. Design interfaces horizontally as independent functional grains, and as small grains as you can make them. Traits are a much more powerful conceptual tool than beginners realize, especially if they have decades of, C mechanical memory, burned into their brains. Developing horizontal thinking skills is a key to unlocking their potential. Explicit lifetimes should be rare. That's true, especially since the 2018 edition. I don't think I need to explain to this particular audience why, so we'll just move on. Still, Lifetime shares some concerns with what I will mention next, which is do not overdo generics. Generics are, very powerful, very useful, but they're not free. Monomorphization costs code and size, and here I'm quoting, Philip from Rockstar directly. Of course, they cost in code size and compilation time, but they cost a lot in readability. If you use Rust for any length of time, you will find yourself at some point struggling to figure out what concrete type a damn generic turns into so you can store it. This was a huge frustration for me at the beginning, in the early days, especially when you're trying to learn and make sense of complicated crates that you're just, getting into. Then, of course, Rust Analyzer came about and has helped dramatically in this regard. So it's not as big an issue as it used to be, but I think it's still, something to be very aware of. And of course, don't learn Rust without Rust Analyzer. But wow, do Rust programmers love their generics or what? I mean, they're all over. Everything is made out of interchangeable blocks, backends, front ends, data formats, algorithms, image formats, everything. You name it, it's a generic. And Rust coders seem to love generic almost as much as they love the builder pattern. Interestingly and happily enough, unlike C, C++ programmers, Rust programmers don't seem to go overboard with macros, which is a good thing. Maybe it's because writing macros in Rust is way harder and people tend to learn them last. So maybe eventually someday we'll have too many macros as well, but I hope not. Anyway, there's nothing wrong with any of these things, of course, but not everything needs to be generic just because it can be. And same goes with builder pattern. And I think you're going to be a lot happier in Rust if you don't overexercise these particular features early in your Rust career. Generics have another cost which they share with explicit lifetime, which is noise. Since both generics and lifetimes are type annotation, they stick to the types. Any data structure that stores a type inherits whatever annotations and must start managing them. And this builds up really quickly. I think that reducing noise in code should be and should remain a priority, especially in Rust, where some of the type syntax is a bit verbose, or at least it can feel verbose. We used to make fun of those C++ template errors. If you have been there, you get these errors that were like 3 pages long and read like complete insanity. And we're starting to see some of those in Rust where, you have these types that have 8 generic types and 3 lifetimes. And, once it's desugared, it's completely unreadable. So I think the abundance of generics in Rust crates is due in part to the fact that authors try to be as compliant as possible. You want to blend in. You want to make your contributions conformant to what is perceived as Rust's best practices, and also to be respectful to what you're building upon. You want to fit in, which brings me to ignore idiomatic pressure. When I first started with Rust, I remember obsessing over everything I was doing to ensure that it would be idiomatic. Now, being strict and obeying the ownership and safety contracts and not writing ridiculous unsafe code or conforming to Rust format conventions, providing documentation, all of these things are crucial to the continued success of the ecosystem. And I think we should continue to stress their importance and emphasize them in Rust education. On the other hand, the obsessive use of functional programming, for example, or generics or the builder pattern, they're not. And, there is no need why newcomers should feel forced to deal with also these things, before they're familiar with the basics. You might be a very experienced programmer, but you are a Rust beginner, and Rust is hard. And I think it's a good idea for beginners to not code to impress, but to code to learn. And finally, you have to banish your residual C++. For C++ survivors, the final hurdle is going to be letting go of pointless C++ conventions, mostly acquired by default, not by logic or even choice. For example, I'll just mention one, which is directly referencing members in data structures. Doing so, it is the unambiguous, clear way to access them. It says that there is no other logic required to operate on that data. Because if there were logic, then there would be a method in the impl. Makes perfect sense. Does it feel strange to poke data straight into structures? Because for a lot of C programmers, especially those coming from environments that enforce the strict rule of getters and setters, it actually feels strange. They feel weird about having the data just sitting there where you can just read it and maybe even write it. But you should go back to it. It's liberating. You need to encapsulate what needs to be encapsulated, and there is no reason at all for all the noise, the housekeeping of getters and setters. When you have, what do you call it? A coding helper software that generates all this crap for you, to me, it says we're doing something wrong. If there has to be an intermediate piece of code that generates a whole bunch of stuff that I don't even need, I think we've gone, too far. Same goes for loose functions. There is absolutely nothing preventing you from creating a very elegant, very, a completely fitting part of a Rust crate that is made only of loose functions. Unless a function has a reason to be a method, it should be loose. It should be just a function, because that tells you everything you need to know about that function and nothing more. The simplest form of an expression should be the preferred one. We should only be adding complexity where it matters. So there you are. 9 ways to achieve happiness in Rust. And I got it done just in time. So Rust is not an easy language to learn. Rust is hard. It is complex and wide. And I think we need to continue to try to find ways, and maybe even formalize ways, to guide new adopters, just to try to make their learning as productive as possible and minimize their frustration. And to do so, we also need to recognize that whichever challenges they're going to end up facing will vary drastically depending on their background. Like I said, I'm speaking for my experience with game development, graphics development, but for someone coming from, making servers or general applications, or I don't know what else, I'm sure it's a completely different vibe. I think it will be interesting to see the adoption curve over the next few years and how it continues. I mean, it looks like it's really hitting that nice exponential bend there. But for us specifically, as game developers, I hope that I kind of get a feeling the game developers overall will be kind of last to fully embrace, but I'll do my best to make that not the case, at least for us. And that is all I have for today. I just want to thank again Philip Delgado from Rockstar and Jason Hayes, also from Reddit Dawn, for their suggestions on this quick chat. Thank you, guys.
Awesome. Thank you so much for your talk. At this point, anyone who wants to go can go, and anyone who wants to stick around, I'll break you all out into different breakout groups. Thanks for coming by and listening to our talk. Sure. Ooh, I'm excited. Cool. Thanks, everybody. I'll create the breakout rooms now, and I hope to see you in there and get to meet all of you.